Wi-Fi first. High-density Wi-Fi everywhere. That's a different approach. And some words about me. I'm André Herkenrath, Principal Systems Engineer at Extreme Networks, now for around 15 years, doing solution architect for sports, venues, and hospitality. And it started with sports. We as Extreme doing this for quite a while, for more than 15 years. Started in New England Patriots in Foxborough, I think it's a place. We had John Burke here and telling us about this. And this went bigger and bigger and bigger. And meanwhile, we are as well in Europe, in Liverpool, Manchester, Berlin, but also in smaller places. And we're quite successful because we have a design approach to Wi-Fi stadia, which is, I would say, quite unique. First, some fundamentals about the very high-density Wi-Fi. It starts with an AP and a person. And the person is connected to the Wi-Fi, and it is like at home, small Wi-Fi, one AP, one person, good service, nearly no noise, yeah, quite fine. He gets closer to the AP, yeah, signal gets better, still no noise level, still everything is fine. He gets away, signal gets weaker, he has a bad service. What are we doing? We increase the transmit power. Okay, that's for small offices quite a good approach. Now we add more people. And what we get is noise. Wi-Fi service is still okay, and now we add even more people. And now the whole thing is damaged. It's crap now. We have too much noise, too many people, signal strength goes down, and that's it. So what's the solution to this? Bring the people closer to the APs. Just make smaller cells. And creating cells in a stadium, you have different approaches that you can do. So the traditional one is overhead. Overhead is quite easy. You go into the canopy or on the roof, you mount your AP, or if you have an AP with external antennas, you do it this way. You tilt it to the people, and then you get some kind of predictable cell size. In the last years, we defined internally in Extreme that we make it to maximum distance of 18 to 20 meters. If you go further away with the AP, then everything becomes too large, you get noise again, and the signal goes down. Here we have some kind of nice representation of this. Some guy from US did some really, really nice artwork to do this. And here we have a good Wi-Fi service, but we still have quite large cells. On the flip side, this is a cheaper way to do this. It is much cheaper to do this, to mount some APs in the roof, than to do our preferred way to do it with an underseat design. With underseat, you get really, really small cells, because you get the people into the cells, you get the people close to the radio. We have a better roaming, the connectivity is wonderful. We calculate around, in a stadium, 70 to 80 seats per AP. The APs are mounted under the seat, you can wash them and do all the stuff, but it's about 70 people per AP. That's the capacity that we do here. And again, somebody made a real good animation on this. You see the bubbles here. It looks quite good. And that's the way we do it in the most stadiums when we can do it. When we have the coverage, of course, we did some simulations. It looks a little bit like Hamina. Some guy from us should have done it this way. And as you can see, at 6 gigahertz, it also works quite well. Sometimes people want to do special APs by putting APs into boxes. That's also something that we tried in the past. Said, okay, we take APs, put them in a box. We had some Excel text box here. And then some guy came up with the idea, hey, let's do some testing. What does this do to the AP? When you look at the APs, the usual indoor APs, they are relying on free-flowing air around them that they can get their heat away. So you see an AP today, like a 4x4 AP, has 30 watt of heat dissipation. That must go away somehow. And if you are in some kind of case that is closed because it has to be waterproof and so on, temperature goes up, the free flow of air is not there anymore. And our quality management found out that if you do it this way, your mean time between failure, your MTBF goes down to 2.5 years. So imagine you have 1,200 APs in the stadium and alone 400 go away, then it's a lot of work. And perhaps the vendor is asking you, hey guys, what are you doing with these APs? Why are there suddenly 1/3 of all APs defective? Another word around the AP quality, 4x4 APs is what we are using mandatory in Stadia. Though the clients mostly only have 2x2 streams, it's just to get signal to the from the clients to the AP, just to have a better signal strengths, and this way, we have a better fan experience here. That's in short terms about our experience in Stadia. But now to enterprise. In enterprise, in the recent years, things completely changed. Since Corona, things changed completely. People could go into home offices, and a lot of people are used to having their laptop connected to Wi-Fi in the home office, sitting in the kitchen, sitting in the living room, or sitting somewhere else doing their work. And then they came back into ugly offices and had to put cable into their laptops. And the whole structure of the way people worked changed. Teams were forming on a daily basis in a different way, and if people were there. On the other side, companies were faced with the fact that their offices were closed. We as Extreme, I think we closed half of our offices, just because the people didn't go there anymore. I'm from Germany, so I have an office in Berlin and I have an office in Frankfurt, and the usual rate of people there is exactly 1. The receptionist. That's the only person that's always there. Sometimes, of course, you have meetings, but that's it. So that's the fact that we have today. And then I talked to a large customer, said, okay, let's do this completely different. Let's go Wi-Fi first, Wi-Fi only. Let's change the paradigm that we do just Wi-Fi wireless connectivity. And so the first thing he found out, yes, okay, if we do this, we save around 20% of our switch fleet. 20% less switches. And with the next exchange, they could order 20% less. And cable management. You see this patching in the patch room, and it is based on the fact that it's done every time. You put a new cable in there and remove a cable, and you put a new cable in there and remove it again, and after some time it looks like rubbish. And every patch room I have seen in my life looked like rubbish because it happened all the time. And then you remove the wrong cable and do not get it. And so we all went through this and had all these nice experiences. And then we have the problem in companies that people move. Teams are new formed. And then some people are not on the same desk where they have been yesterday. They're on a different desk. And then the company has to decide, okay, we have 2 options, exact 2 options. The first option is we put a live Ethernet link to every jack that we have in our company, which means that it results in 50% unused Ethernet ports on your switches, which is not very clever because you're paying a lot of money for these devices and they're not used. The other option is you have a help desk team that runs around and patches the Ethernet jacks when the people are moving. And they do not tell you that they're moving, they just move, and then they call you, I have no connectivity anymore. So you have help desk calls. By moving to Wi-Fi wireless, everything is different. They move from one desk to the other desk, they don't need a cable, and then they can have their connectivity again. DHCP scopes are less, number of VLANs can be less, so it's much easier to manage a network. And I was in an office in Birmingham where they did exactly this. They had a 19-inch rack in the middle of the room with 6 switches, all running their lines to the desks. After they were done in the main room, it was some kind of call center, only one switch. That's it. And there was a small cabinet mounted to the ceiling, and it looked much nicer, and the people loved the new way how their offices looked. But there are some problems. 2.4 gigahertz. I consider it as dead. These pictures have been made in an insurance company in southern Germany, where they said we have large problems with our guest Wi-Fi. It simply doesn't work. And then we found out that there were a lot of IoT devices not running Wi-Fi, but running something different on the free spectrum. So Wi-Fi, this didn't work. And then there's another problem. This is a real-life GTEC case. There's a call center in Istanbul, in Turkey. And they had an open space, 250 square meters, and they were heavily doing Teams and all this calling stuff. And they said, we have ping times that are bad, our connectivity is bad, your APs are bad. They had 3 APs, 305C from us, which is a 2x2 AP, the smallest one you can get, Wi-Fi 6, running on 2.4 and 6, on 5, sorry. And we looked at it, yeah, no capacity. They simply had no capacity. And that's something you have to consider. You cannot calculate capacity. That's, by the way, a YouTube video from Peter McKenzie that inspired the next slide, together with the Wi-Fi airtime calculator from Gernot. You have a PHY connectivity. On the PHY, maybe you have 150 megabit or 300 megabit or something, but that's not your throughput. If you really look at the throughput, it's much, much lower. For example, in these 2 examples, we have one application that has very, very small payload. It's only 200 bytes, something that could be some voice thing, and your throughput goes down to 4 megabit. Because you have so much control traffic and so less real payload. So here is key that you know the applications your customer is using. That's absolute key. And you have to create the capacity accordingly. And that's what we did in a customer, in a real-life scenario in Sweden. The customer decided Wi-Fi only, so no Ethernet jacks, just some Ethernet jacks for printers, but more or less Wi-Fi only. And then we went into this building, fresh new building. It was a company, I would say, tons of money meet Scandinavian design. Very nice building. It was an energy company, so they have money. And we did not a real survey. We just decided to place the APs where the people are, like we do it in Stadia. So we have the people here, we have a high density of people, then we put here more APs. And in other areas where we had less people, we put fewer APs. And then we did a user acceptance test. We brought users, real users that saw this building for the first time. They have been there for the first time, and they brought their laptops with them, their iPads, their iPhones, and all that stuff. And they started with the user acceptance test. Their main application is Teams. The blue bars, the blue blocks here are because I cannot disclose the customer name. And we ended up with 35 Teams sessions on one AP. That was what they wanted to have, 35 sessions, no problems. Then somebody started a high-density YouTube video. Done. So we got dropouts, and it simply didn't work anymore. But we now knew that's the capacity we have here. And it went very well. Customer is absolutely fine with it. And yeah, that's the real-life scenario. Some other things we need to consider, I think everybody knows that an Omni AP is not really an Omni AP. It goes into a different direction, and sometimes people write in their data sheets, we as well, you can mount it to a ceiling, you can mount it to a wall, but you shouldn't mount it to a wall, you should mount it to a ceiling. So another graph shows what can happen if you don't do it in the right way. So you see on the left side that's the correct placement of the AP. You have coverage everywhere. On the right side, you have coverage holes. After we have done everything, we need to monitor. And that's something that we have in our platform, that we also look into the Wi-Fi capacity and really look how our capacity develops over time. So if you look like this is total crap. You have not the right capacity for the clients, and then you get into issues. Yeah. I have one more slide, and that's an important slide. It's the most important slide. Today at 7:30 p.m. in Zurich 2, I don't know, it's over there, we have the Extreme Party. We will have some beer, we will have some snacks, wine, and we have free APs. You need to register to get the free AP. The first 100 people who register get the free AP. I think we already have 50, 60 on the list, so you have to be fast to get one. Yeah, and I hope every one of you will be there. We will have some presentations. My colleague Chris will tell you something about UZTNA, and that's it from my part for the moment. Thanks a lot.